Alright, ladies and gentlemen, we're going to start off today on page 203 from your workbook. So go on ahead and change to page 203 and make sure you're there. Our first example is going to go on ahead and ask us to graph these four functions. To make it a little easier for you to follow along, I'm going to go on ahead and graph each one of these functions in a different color. I'll graph f of x in blue. The equation is 3x. And since there's no plus something here, it's almost like it's plus 0. So I put my first dot at 0. I go up 3 over 1, and I draw the line connecting these points. Now these graphs are going to be pretty close together. So what we want to do here is we want to try and be as accurate as possible so that we don't crowd up our graph. Let's go with g of x next. It's g, so I might as well graph it in green. My y-intercept is 1, so I want to go up 1 and put my first dot. Normally I would count up 3 and run to the right 1. That's not going to work out, so I'm going to go down 1, 2, 3, and to the left 1. So you can start to see how close these lines are going to be. And I know that's frustrating for you when you don't have your own ruler, because these are going to end up pretty close. Let me go on ahead and graph h of x really quick. I'm going to do that one in purple. And then I'm going to do q of x in red, because it's the only one with a negative number. So I've gone on ahead and I've graphed all four lines, and they are color-coded. The first question asks about the intercepts. What are the intercepts of each one of these? So the intercept for f of x is the intercept for the blue line. Where does the blue line cross the y-axis? Well, it looks like it crosses it right there at 0, 0. So f of x is going to be 0, 0. G of x was for green, and it looks like it crosses the y-axis at 1. But remember, we want to write that as an ordered pair, so it is going to be 0, 1. H of x was our purple. It's all the way up here at 2, so that would be 0, 2. And then q of x, that one's the red one, and it is at 0, negative 1. The next questions ask, how could you describe the translation of h of x from f of x? So what that actually is saying is, if I start at f of x, the blue line, what happened to get to the purple line? Notice my blue line's down here, and my purple's been bumped up 1, 2. So to go from blue to purple, I want to say that it was shifted, and I guess we could say f of x shifted up 2 units. And again, the way I did that is I looked at my blue line, and I said, okay, this point was on my blue line, 1, 2. To get to my purple line, I had to count up 2. A kind of cool pattern emerges. F of x is 3x, and h of x was 3x plus 2. So notice if I shift it up 2 units, this equation has that plus 2. Let's try another one and see if that's just a coincidence. How could you describe the translation of q of x from f of x? So again, I start with my blue line, and then I go to my red line. Well, if I start at my blue line, and then I go to my red line, it looks like in order to go from blue to red, I had to move down 1 unit. So I would say f of x is shifted down 1 unit. And sure enough, if we take a look at their equations, f of x was just 3x, and then q of x is 3x minus 1. Down 1 unit, and notice the change over here. Alright, we got one last one. how could you describe the translation of q of x from g of x? So I want to start with g of x. I did that wrong. I want to start with g of x and go to q of x. So I want to start with the green one, and then I want to go to the red one. I just want to go on ahead and pick a point on my green graph and count how far down. It looks like every point on my green graph would be down 2 units. So I want to say that g of x is shifted down 2 units. Now, based on what we've seen above for these two, maybe we would see an equation with like a minus 2. But it's going to look a little different, and I want to see if you can figure out why. So g of x, if I look back at the top of my page, g of x was the equation 3x plus 1. And q of x was the equation 3x minus 1. And yet, it shifted down 2 units. But there's not a 2 over here. What I want you to notice, though, is this is a plus 1 and this is a minus 1. So the difference to get from plus 1 to minus 1, well, I'd have to subtract 2. 1 minus 2 would give us negative 1. Interesting, interesting, interesting.